The 1998 Cadillac Seville STS was designed to compete at the highest level of the luxury market, but its owner's manual contained a very unusual set of instructions. It explained how to keep driving the car while the engine was failing. If the engine lost its coolant on the highway, it would not seize. Instead, the Northstar V8 would reconfigure itself, shutting down half of its cylinders so they could pump air and manage heat. Cadillac called this system limp-home mode, and they were confident enough in its design to state that the car could be driven for up to 50 miles without coolant. On the surface, it appeared to be a sophisticated safety feature, but it raised a more fundamental question. Why would a flagship luxury engine need to operate without coolant in the first place? The existence of that system points to something deeper. It suggests that the car was designed not just for performance, but for a very specific kind of failure. The ambition behind the Seville was real, but years before it reached the market, a single engineering decision had already set its limits. One that would go on to damage the reputation of the Northstar engine and eventually undermine the identity of the entire nameplate. So, how does a solution like this end up defining the failure of the car it was meant to protect? To understand that, you have to look at what Cadillac was trying to prove in the 1990s. The brand had spent nearly 2 decades building cars for people who valued comfort above all else. Soft suspensions, insulated quiet, interior appointments that whispered luxury instead of demanding attention. Floaty highway rides that disconnected the driver from everything happening beneath the tires. The target was older money, people who'd bought Cadillacs for years, whose parents had bought Cadillacs before them, who saw no reason to break the habit. And for a long time, that worked. But the market had shifted in ways Cadillac's executives couldn't ignore. BMW and Mercedes had captured something the brand couldn't seem to reach anymore. Buyers who wanted luxury wrapped inside performance. Not just straight-line power. American cars had always had that. They wanted to feel the road. They wanted acceleration that pressed them back into leather seats and steering that communicated something beyond direction. They wanted the car to feel alive underneath them, not anesthetized. Cadillac's internal product planning documented this exodus with precision. Customers with brand loyalty, people whose fathers and grandfathers had owned Cadillacs, were trading them in for German sports sedans and not coming back. The DeVille was still profitable. It still sold. The older buyer who wanted isolation could still walk into a Cadillac showroom and find exactly what they'd always found. But the DeVille signaled surrender. It conceded the performance luxury market to Germany and retreated to the comfort fortress. The STS was built to signal refusal. It was Cadillac's direct response to the BMW 5 Series and the Mercedes E-Class. Not a competitor built for Cadillac's traditional buyer, but a competitor built for the buyer Cadillac was losing. Both the STS and the DeVille shared the same platform, the same front-wheel drive layout, the same basic architecture underneath. But the STS received a completely different calibration. The engineers tuned the suspension for sport instead of comfort, added electronic damping that adjusted the shocks in real time based on road surface, fitted performance tires instead of touring rubber, stiffened the chassis mounts, recalibrated the steering for quicker response. The continuously variable road sensing suspension, Cadillac's own electronically controlled damping system, was specifically calibrated for the STS to prioritize body control and cornering composure over the marshmallow ride the DeVille delivered. On paper, the two cars shared a platform. In the driver's seat, they were instruments built for fundamentally different purposes. The STS was what Cadillac could do when it stopped chasing comfort and started pursuing capability. The Northstar V8 was the centerpiece of that pursuit. What gets lost in the failure narrative is that the Northstar V8 wasn't some rushed knockoff or a cost-cutting exercise disguised as engineering. It was a genuine achievement that deserves to be understood on its own terms before the story of its collapse begins. The Northstar made its production debut in 1993 inside the Cadillac Alante, a 2-seat roadster priced at approximately $60,000 when most domestic luxury sedans sold for half that. It also appeared simultaneously in the Eldorado, ETC, and the Seville STS of that model year. The engine didn't get tested first in a mainstream sedan or a volume product. It debuted in the most expensive and most prestigious vehicles Cadillac made. That placement was intentional. GM's engineers were announcing something specific. This engine belongs at the summit of the brand hierarchy. What they built reflected that positioning. All aluminum block and heads meant starting from scratch. No cast iron anywhere. 4 separate camshafts instead of 1, which meant 4 valves per cylinder instead of 2. In 1993, that was still sophisticated technology for a domestic engine. European manufacturers had been building DOHC engines for years, but American manufacturers treated them as boutique complexity, expensive and difficult to manufacture at scale. Cadillac's product planning decided to absorb that cost because the engineering payoff, lighter weight, faster response, better breathing at high RPM, was worth the investment at the flagship level. The weight savings from all aluminum construction weren't just a number on a specification sheet. They translated into something engineers could feel. The Northstar was substantially lighter than the iron block engines it replaced. In a front-wheel drive car where the engine sits directly over the front wheels, that weight reduction improved balance and handling in concrete, measurable ways. Lighter components mean faster throttle response. Faster response means the engine can rev more quickly when the accelerator opens. The all-aluminum architecture made the engine feel alive, in a way that iron block American V8s of the era simply didn't. The initial L37 version produced 295 horsepower, immediately competitive with European V8s of the same displacement. Ward's Auto World named it one of the 10 best engines in North America. By the time the 5th-generation Seville STS arrived for 1998, the output had been refined to 300 horsepower in the high-output version, with 275 horsepower in the more relaxed SLS specification. Period Automotive Press positioned the Northstar directly against BMW's M60 and Mercedes' M119 V8 engines, not as a challenger playing catch-up, but as a documented equal. The engineering was modern, the output was competitive. For the first time in decades, a Cadillac powertrain could be discussed alongside German engineering on pure technical merit. That confidence carried through every application that followed. The Northstar went into the Eldorado, the DeVille, the Oldsmobile Aurora. Each time, Cadillac positioned the engine as the technological centerpiece. The DOHC 32-valve architecture meant the engine could breathe. The all-aluminum construction meant it could respond. Everything that followed, the 5th-generation Seville, the positioning against the BMW 540i, the explicit horsepower advantage, flowed directly from that foundation of engineering confidence. GM's development of the Northstar had begun at Oldsmobile R&D as early as 1984, in anticipation of the advanced DOHC V8 engines that European and Japanese competitors would introduce later in the decade. The engine represented nearly a decade of investment before it ever reached a customer. That investment was real. The ambition was real. And for a brief window, the achievement was real too. But there was one engineering choice, made during the design phase and documented nowhere prominent, that would eventually destroy everything the Northstar was supposed to accomplish. And the failure mode itself has been almost universally misidentified. When people talk about the Northstar failing, they talk about blown head gaskets, as if the gasket material simply burned through. That's the public narrative. The actual failure is something more specific, and once you understand it, the entire story changes shape. The Northstar's failure isn't the head gasket material giving up. The failure is the aluminum head bolt holes in the block stripping their threads. The bolt holes fail first. The gasket fails only as a consequence. Here's the physics. In a conventional iron block engine, steel head bolts thread into iron. Iron has high thread shear strength. The bolt clamps down with substantial force. The material resists, and the joint stays sealed across thousands of heating and cooling cycles. It's a solution proven across a century of engine building. But the Northstar has an aluminum block. That choice, which saved weight and enabled the responsive performance everyone celebrated, created a fundamental incompatibility at the fastener level that nobody seemed to prioritize during development. Steel head bolts threading directly into aluminum holes creates a mismatch at the material level. Steel and aluminum have different thermal expansion coefficients. When the engine heats up during operation, they expand at different rates. When it cools down, they contract at different rates. Over repeated thermal cycles, thousands of them across normal driving, that differential expansion and contraction works the aluminum threads progressively loose. The threads don't fail catastrophically. They yield gradually. Thread engagement reduces incrementally. After enough cycles, concentrated in the 60,000 to 120,000 mile range, the clamping force becomes insufficient. The head gasket loses the pressure holding it sealed. Coolant finds its way into the combustion chamber. The solution existed before the Northstar was ever drawn. The automotive industry had known about it for decades. Steel thread inserts, commonly called time certs or helicoils, create steel-to-steel thread engagement between the bolt and the block. The insert's outer threads engage the aluminum at a much lower shear stress per unit area than direct bolt-to-aluminum contact. The bolt threads into the steel insert. Two compatible materials working together instead of two materials fighting their incompatibility across every thermal cycle for the life of the engine. GM did not specify steel inserts in the original Northstar design. That's the decision. Not a technical limitation. Not an engineering discovery that came later. A choice made during development that prioritized something else. Cost, probably, or production schedule, or manufacturing complexity at the Livonia engine plant, over the durability solution that the industry had already proven. GM eventually approved time cert as the only authorized repair method for the Northstar head bolt failure, which tells you everything about what should have been there from the beginning. The company validated the exact fix it had chosen not to implement. The consequences began appearing in the early production population. NHTSA complaints from 1993 and 1994, Allantes, documented coolant loss. Complaints accumulated through 1995, 1996, 1997. Dealers were seeing the pattern. Owners were experiencing it, and OGM's own internal data flagged the failure as systemic enough to warrant warranty extensions on specific VIN ranges, documented in GM service bulletins whose VIN boundaries show which production periods the engineers determined were at elevated risk. The company had identified the pattern. The company had acknowledged it formally. And then the fifth-generation Seville STS arrived in 1998 showrooms, positioned against the BMW 540i, carrying an engine whose failure mechanism was already well documented in the complaint databases and the service bulletin archives. The horsepower advantage over the BMW was real. The performance on the test track was documented. The engineering ambition was genuine. None of it mattered because the fundamental durability of the engine was compromised by one fastener decision made years before this car ever existed. GM's engineers anticipated what would happen when the head bolts failed. They understood that an engine losing coolant without warning is catastrophic, and that aluminum warps faster than iron under thermal stress. So they built a specific provision into the Northstar. When the system detected significant coolant loss, the engine changed its combustion pattern, reducing the number of firing cylinders to cut thermal load dramatically. The engine produced just enough power to move the car slowly. At thermal loads, the aluminum could theoretically survive without coolant for a limited time. The owner's manual documented limp-home mode explicitly. Approximately 50 miles at reduced speed. Proceed to a dealer immediately. Do not attempt to diagnose the coolant loss yourself. Do not drive normally. This is an emergency provision, not a solution. The problem was what owners understood limp-home mode to mean. NHTSA complaints documented the pattern. Owners experiencing coolant loss engaged limp-home mode and kept driving. 50 miles, 100 miles, 200, 300. The car kept running. The temperature gauge didn't spike catastrophically. The engine didn't seize. To owners, limp-home mode looked like proof that Cadillac had engineered the Northstar to survive without coolant. What they were actually doing was driving a damaged engine progressively deeper into failure. Extended operation without coolant doesn't just create initial damage, it creates compounding damage. Aluminum heads warp under sustained heat. The block distorts. The geometry the design depended on begins to change. By the time an owner reached a service facility, after 300 miles on limp-home mode, the repair wasn't a $2,000 thread insert job. It was a $4,000 procedure, or $6,000, or, in worst cases, an engine replacement because the internal damage had cascaded beyond what any thread repair could address. The limp-home mode transformed from an emergency safety provision into a trap. It made the problem worse because it enabled owners to ignore the problem. GM's engineering foresight, intended to provide a controlled retreat to safety, instead enabled owners to extend the damage progressively. The car's ability to limp home actually prevented owners from treating the failure as the emergency it actually was. More critically, it changed what the failure meant to owners at a level that engineering couldn't reverse. The perception crystallized quickly. Cadillac knew the engine would lose coolant. Otherwise, why build limp-home mode into it? The company had anticipated the failure, and instead of preventing it, had engineered a workaround. That was the perception. It wasn't entirely fair. Limp-home mode was designed for any coolant loss scenario, not specifically for head bolt failures. But the perception didn't care about fairness. The warranty extensions couldn't keep pace with the failure rate. Dealers were performing repairs outside warranty coverage because the volume of failures exceeded what the programs anticipated. Independent shops were encountering the failure often enough to develop their own diagnostic shortcuts. The STS's reputation didn't collapse because of the engineering failure alone. It collapsed because owners interpreted the failure as confirmation that Cadillac had known about the problem all along and chosen to make it survivable rather than reliable. That interpretation was more damaging than the repair cost. A car that breaks can be fixed. A brand that anticipates its own failures and builds workarounds instead of solutions loses something that engineering can't restore. By the early 2000s, the damage to the STS's reputation was accumulating beyond what engineering revisions could repair. Every owner who encountered coolant loss joined a growing population, warning others away. Every service bulletin reinforced the perception that Cadillac was managing a crisis rather than building a competitive product. The competitive window against the BMW had closed. The STS's position weakened, not because the Northstar had lost horsepower or the car had gained weight, but because the competitive frame had shifted entirely. The BMW's handling advantage became impossible to overlook. The inherent limitations of front-wheel drive, torque steer under hard acceleration, the understeer tendency at the limit, the steering feel that no amount of calibration could fully overcome, weren't small deficiencies anymore. They were the substance of the comparison. You could calibrate a suspension. You couldn't calibrate away the physics of the platform layout. Cadillac's engineers had understood this constraint from the beginning, but cost and timeline had made the existing front-wheel drive platform the pragmatic choice in 1998. The platform's development had been amortized across DeVille production. An entirely new architecture would have required authorization at a corporate level that GM's product leadership had been unwilling to grant. Profit margins on trucks and SUVs were funding the company. Luxury sedans weren't the priority. By 2002, ignoring the situation was no longer possible. Product planning authorized development of the Sigma platform. Rear-wheel drive weight distribution, rear-wheel drive steering feel. Everything the STS couldn't be. Sigma represented GM's most significant luxury sedan investment in years. Not a refresh, not a platform evolution, but a completely new foundation. You don't invest that kind of capital in a new platform architecture unless the existing one is terminally compromised. The front-wheel drive limitations were real, but they alone weren't going to trigger a complete platform replacement. Companies live with architectural compromises for decades when the economics work. The Northstar's accumulated reputation damage was different. That was the decisive factor. The engine's reputation was what made continuing on the existing platform commercially impossible and what triggered the entire reset. The fifth-generation Seville's production ended after the 2004 model year, 7 model years in market. And when the Sigma architecture was ready for 2005, Cadillac made a decision that documented the full extent of the damage. They didn't call the new car a Seville. They retired the nameplate. The Seville name had been in Cadillac's lineup since 1975. 29 years of nameplate history, brand equity, marketing momentum, customer recognition. 5 generations of continuous production. The car that had earned Motor Trend's Car of the Year in 1992. The car that had introduced the Northstar to the lineup. The car that had been Cadillac's explicit answer to the BMW 5 Series for an entire decade. The new Sigma car was positioned against the same competitors. It used Cadillac's same design language. It carried the brand forward into a new era of rear-wheel drive performance sedans. But it wore a different name, the Cadillac STS. Product planning had determined that the Seville nameplate's association with the Northstar's failure was more damaging than the value of 29 years of brand equity. Consider what that calculation tells you. The name that had represented Cadillac's performance ambitions since the Ford administration, the name that had been placed directly against BMW on billboards and magazine ads, was now considered a liability so severe that carrying it forward would actively hurt the product it was attached to. The name had to die with the platform. Start fresh. Carry nothing forward that connected the new car to what had failed. That's not a product decision. That's an amputation. Companies don't abandon 29-year nameplates because of engineering limitations or market repositioning. They abandon them because the name has been poisoned. The Seville nameplate was poisoned by head bolt threads. The Sigma STS offered a 3.6-liter V6 and a 4.6-liter Northstar V8, but now in a rear-wheel drive configuration, whose weight distribution and thermal cycling pattern reduced the head bolt failure rate. The rear-wheel drive layout changed how the engine's heat moved through the block and heads. The failure became less common, though never entirely eliminated. The new architecture gave the Northstar a chance to succeed where the front-wheel drive platform had made success impossible. But the name Seville was gone. It never came back. The Sigma STS itself was discontinued after 2011, and neither the Seville nor the STS nameplate has returned to Cadillac's lineup. The damage outlasted the car, the platform, and the engine that caused it. Today, any Seville STS still running on the road exists in one of two states: repaired or living on borrowed time. The documented solution is the Time-Cert retrofit, GM's own approved repair method. A specialist drills out the stripped aluminum threads in the block, installs steel-threaded inserts, and restores steel-to-steel engagement between the head bolts and the block. The repair installs what the original design should have contained. The cost runs approximately $2,000 to $4,000, depending on scope. The repair works. Documented cases in the Northstar service community show that properly installed time-certs don't refail at the same location. The failure mechanism, differential thermal expansion between steel and aluminum, is eliminated when both the bolt and the engagement surface are steel. Purpose-built Northstar time-cert kits became commercial products because the repair community understood the failure precisely. They knew exactly what had failed and exactly how to fix it. But the repair creates a binary outcome for ownership. An STS with documented thread insert work is manageable. An STS without it is high risk. The service history becomes the single most predictive variable in evaluating any example. Not mileage, not body condition, not transmission function, whether the head bolt repair has been performed. Current market values for functional Sevilles range from $2,000 to $5,000. At that price point, the repair cost represents a significant percentage of acquisition value. A buyer who purchases at $2,000 and performs the time-cert retrofit invests approximately $4,000 to $7,000 total. That investment produces a vehicle with a corrected Northstar whose remaining service life is governed by standard wear items instead of a known systemic failure. The repair becomes economically rational if the car's condition warrants the investment. The rest of the mechanical package was never the problem. The 4T80E transaxle was shared across the DeVille, the Eldorado, the Oldsmobile Aurora. Cross-platform deployment meant any Cadillac specialist shop accumulated experience across years of service. Solenoid wear at high mileage is documented and manageable. Torque converter shudder is a known wear item with established solutions. The suspension aged predictably. The electronic damping system worked. Brake wear followed normal patterns. Everything functioned except for one thing, and that one thing was everything. The Cadillac Seville STS was Cadillac's moment to reclaim the performance luxury market. The Northstar had the horsepower. It had all aluminum engineering. It had competitive positioning against BMW that was documented on the test track and confirmed in the magazines. The achievement was real. Ward's Auto World named the engine one of the 10 best on the continent. Period road tests confirmed the acceleration numbers. For a brief window in the late 1990s, Cadillac could honestly claim it had closed the engineering gap with Germany. Not as aspiration, but as documented fact. One decision destroyed that claim: steelhead bolts threading directly into aluminum block holes without steel inserts. Not a design flaw in the combustion architecture, not a materials failure in the gasket compound. A thread engagement choice that the automotive industry had already solved, that GM chose not to implement, and that GM later approved TimeCert to repair, validating the exact solution that should have been specified from the factory. The consequences cascaded beyond the engine bay. GM retired the Seville nameplate rather than carry it forward, proving the reputational damage had become permanent. 29 years of brand equity abandoned because the association with one engine's failure was more toxic than the value of the name itself. The Northstar's head bolt thread stripping didn't just kill engines, it killed a nameplate. It changed Cadillac's entire platform strategy. It accelerated the development of the Sigma architecture by making front-wheel drive continuation commercially impossible. It forced the company to start over with a new designation, a new drivetrain layout, and a new identity built specifically to distance itself from what had failed. The limp-home mode, intended as an emergency provision, became the symbol of the whole story, a feature that told owners the engine could survive without coolant, when what it was actually telling them was that the engine expected to lose coolant in the first place. The engineering foresight that should have been applied to the head bolt threads was instead applied to surviving their failure. GM's engineers solved the wrong problem brilliantly. The Seville STS proved that a domestic manufacturer could build an engine that matched European V8s on horsepower, sophistication, and responsiveness. The market proved that none of that matters if the engine can't hold its head gaskets past 60,000 miles. Engineering ambition without engineering durability is worse than no ambition at all, because it creates expectations and then destroys them, and the destruction is remembered longer than the achievement ever was. The cars that survive today do so because one repair, the TimeCert retrofit, was performed, or because the failure was caught early enough to prevent cascading damage. An informed buyer's due diligence question for any Seville STS is straightforward. Has the head bolt thread repair been documented? That single answer predicts more about the ownership experience than mileage, condition, accident history, or service records combined. The car's engineering was competent. The suspension worked. The transmission was sound. Everything functioned except for one thing, and that one thing was everything. Click on this next video about the Lincoln Town Car to see the car that understood what Cadillac forgot. The Northstar proved Cadillac could match Stuttgart on the dyno. The head bolt threads proved it couldn't match Stuttgart in the driveway.